Hello everyone, welcome to Introduction to Deep Learning Exercise 7, Pytorch. So today's outline is, first of all, we want to recap the exercise 6, and then we have an overview of Pytorch, and then goes our optional submission. It's also an optional, but it's also good for you for the later exercise, and then some problem with the organization. First of all, it's the exercise 6 recap. Here I just get the results for exercise 6 in our leaderboard. Actually, some users get really nice scores, more than the borderline for pass the submission. So congratulations to those autonomous users. And actually, I also get the results of this task image classification on Cypher 10. It's in the website of Papers with Code. It reports the newest or the best results of the published papers. Here we can see actually on Cypher 10, it's this year already achieved 99% results. Yeah, it's the same data used like yours, but it's okay since there are some limiting factors that may limit your performance is far away lower than the best results on this benchmark. First is the computation power, or the time. Actually, now you are just using some basic functions implemented by yourself. Do so, but many good project or the results may come from some powerful frameworks like Pytorch, and also they may have better GPU support. They can have large batch size during the training to support it by a huge GPU memory, and also they have different like data augmentation stuff. And also another thing is quite important for deep learning project is the specialized architectures. This is what we do as researchers. Mostly papers are concerning to do. Like they may use convolutional neural network, namely CNNs, that we are covered in lecture 9, to do the task on image understanding or computer vision. And it may also have more knowledge like a proper initialization for the network training, or any other stuff that may affect the training performance. You can find it from the lectures. So here we go a recap of the initialization. You may already have it in the recent lecture. It means actually we should not actually just initialize the weights very randomly or use or zero. It should be tolerated to our active functions. Like in exercise 6, we have a small Gaussian to do so. Yeah, we compute the SGD, and also maybe use the Gaussian function to randomly initialize the parameters. It may help a little bit. And then let's go to this exercise, Pytorch. So let's first go to the exercise overview of all the exercise you need to do for this course. In the beginning, we have some intro part like the organization and also the math recap. And what you already achieved is actually many use the NumPy and then reinvent the wheels or the pillars of a deep learning project. In exercise 3, you have get access to the dataset and also the data loader, and then you know the solver, and also trying to some very basic models like a linear regression, and then you start from to train a neural network and train a lot to tune in the hyperparameters to trying to make the network get better performance after your training. And from this exercise and the next one, we will use the very famous framework Pytorch, and also a tool called TensorBoard. In this exercise, it's an introduction to Pytorch, and the next one is to use Pytorch to do a very simple task called autoencoder. And then we will have more applications. Yeah, you can just use what you learned from the recent exercise to do more interesting training tasks like convolutional neural network and also semantic segmentation task or even RNNs. So here, I want to introduce some very famous or common deep learning frameworks. They are actually have the two dominated one from two big company. One is Google, and the other one is Facebook, namely Meta. The TensorFlow is from Google, and then Pytorch is from Facebook. Both two are very popular in our deep learning community. But here we choose Pytorch is because I think it's easier for beginners to get familiar with a framework, and Pytorch is I think recently it's quite more popular than TensorFlow for the academic research. When you find recently a deep learning paper, it have a big chance to share its code. You can find on the internet. It's right from the Pytorch. And actually, there are other frameworks you can also try to use. Yeah, like from the other company, Microsoft and CNTK, and also MXNet is also quite popular for a while, and then Google JAX. So what's the difference between those frameworks? I would say it's different paradigms. For TensorFlow and Pytorch, the graph correction is in a different way. For TensorFlow, it's in a static way, more like similar to the program language C, and the Pytorch one is with a dynamic graph creation. It's more similar to Python. And also another question is what you now using a framework for training or develop a neural network, and then maybe you want to convert and optimize it in the real application. Here we can use some framework conversation. You can use one your favorite framework to develop and train your network, and then trying to convert and optimize the train network to a target framework for production. That also works. Okay, let's get an overview of Pytorch. It's quite similar with what you do with NumPy. It's actually three pillars: data, model, and optimizer. Different from the functions you reinvent from by Python and NumPy. Here in Pytorch, actually, it already include everything, almost everything you need. Like for data, they have the Torch UTLs. It have many useful functions. And for Torch Vision datasets, you don't even need to define a very common datasets like Cipher10 or ImageNet part or other 3D datasets. You can directly import some library or functions from the Torch Vision dataset. It just maybe a one-line code can make it to load the dataset. It's already here, and also it have like Torch Vision transforms. It's for data augmentation. You can directly use some functions here to that it may be helpful or used in your data loader. And for models, it's the same. You don't need to define everything. Here in the Torch .nn, it already have some functions to define some module or some block by a very, very simple line. And then have in the Torch Vision, the models, it already have some very common network like ResNet. Maybe it will be involved in the afterwards lectures, and also some basic functions of the model like a ResNet block or other common backbone for the vision model like a VGG. It means the models you don't, if you use the model from the previous work or the very common work, you don't need to define it layer by layer. You may just input the model from the library Pytorch already provide. And for optimizers, in the same way, you don't need to define the every hyperparameters in a line and then organize a function here. In the Torch, the optimize this part, it already contain many popular optimizers. You can directly use it. What you need to do is to change the hyperparameters you want to use in your training during your training. Yeah, okay. So here's some key features you need to know. So first of all is the simple device management. Right here, you can actually for Torch, Pytorch, here we import Pytorch as Torch here. You can check whether the GPU is available or not. That means your device for this your current training project or task is by GPU or by CPU. And then what you need to do is to put everything, your data and also your model to the device what you are doing. You can simply use like X to device to put the X to this device, and then that can be simply manage the device you are using. And also what you need to implement is some optimizers like in the exercise 6, you already have some ideas of how to tune in a training network to make it work better. And then here you can use many popular optimizer, but you still need to tune in it by your own task. And also the dataset, what dataset you want to use. Here we use 710 again, and also how to compute the automatic gradients to backward the loss function, and then to optimize the weights of the neural network. Okay. So here is an example of the easy network creation. Here we just import the torch.nn as nn. That can help you to create some basic functions when you're defining a neural network. Then you define the model like we name it as class net. And then what you need to do is just to edit the layers here. Like here, you just use add a layer with the input side and the output side, and then you can have a linear layer here. And you also need to define the forward path, like for the input of this network is X, and then you need to forward X to the models or layers in your network initialization, and then just forward it. What you need to do is to just call this class and then make the network or the model to the device you are now using, and then you pass the data already in the same device to it and output it. There maybe goes a question, where is the backward path? Actually, for the forward path, you already get the input here, and then forward your data in the network. What you need to compute for the backward path is to actually, when you compute the loss function, and then you can directly use the loss backward to backward the everything, the weights, and to optimize the weights by a backward path. Here you can refer some repo like the GitHub one, the official GitHub one, or I also recommend you to get familiar with some examples provided by Pytorch. It can be very helpful. It already have some examples to how to train a neural network, and also you can read the Pytorch for NumPy users, and then you can look up your own and share it with your classmate. Okay. Then except the Pytorch, we also have another very important tool for for your neural network training, that is TensorBoard. The name is quite similar to TensorFlow, and yes, it's from Google, from the TensorFlow team, but I think it's quite useful for the training process of a deep learning project. We also use it when we choose the Pytorch framework. You can directly import the library, or it's also contained in the Pytorch as well. Here, what you do is to directly access the TensorBoard in your training loops. What TensorBoard do is to actually generate the graph or the time step for you. Like here, you want to record those functions in each iteration. Since we want to monitor what's going on with the training process, right? You don't want to, sometimes you train for a while, maybe then you find your loss function is network is not decreasing. So it will be good if you can monitor the training process by a graph style instead of always logging the loss value. It's more easy to read by some graph, right? So that's what a TensorBoard do. So not only for the graph or the numbers you want to plot in the figure, but also you can also visualize the network by a simple single forward pass. The bot can map and display your network graph by it. And also, actually, it can document everything you want to show. Like for the input of the image, you can also display here by image, and also some histograms for during your training or your tuning. Everything actually you can save or use some functions in TensorBoard and then to display here. One example is to do weight initialization. You can actually visualize the histograms for layer output can show the efforts of weight initialization, and then you can as it show in the lecture. Here you can show some visualizations, and then you can display it from the TensorBoard. And more abstraction is Pytorch lighting. Here, we already know the Pytorch, right? But it's not simple enough. People say, okay, we can make it more simple by classify the code into 3 categories. Like the first one is the research code. That's the most exciting part. Since in each project you want to change something, right? You want to maybe change the model a little bit, or just to change the task a little bit, like use the same model for a slightly different task, or for the same task you can use test different models, how they performance differently with it, right? And also this is the research code. And actually more stuff is about the engineering code. Actually for all the project or the models, you need to do something fixed, right? Like you define the training loop for iteration, and then how to backward the loss functions after you compute it, and what this is actually in the China part. And also you have some non-essential code like login, organizing the runs, or directly just like you maybe want to display some intermediate results or the loss curve via the TensorBoard. This is a non-essential code, or some checkpoint when you optimize your training process, right? So what Pytorch lighting model is doing is to make it more simplified. Like in Pytorch, we define the model and then have a forward pass of the training. Like we get the training loader and also define the neural network, and also we utilize the optimizer and the scheduler, and then for the training loops, like here we use 100 iterations. We do it for each pass to compute the loss functions and backwards the loss. And what we do here for Pytorch Lighting is to modularize every part into a function or a class. And then what you need to do is to implement is to initialize the model and then the forward part, and then define the training steps and the optimizers in function. And you do to training is just call the trainer, and then you use the feed function for training the network. So here you do is to just select the model, and then the trainer actually already contained all the code relatively relevant to training our neural network. And then what you need to do is just to call it the feed for training the neural network. So the advantage of using Pytorch or Pytorch training or Pytorch lighting, those tool is to you have a better overview of the relative code. It have some nice debugging features. You know how to change which part should be changed during your training, right? You're implementing, and then it have many automatic options like login, or you want to visualize something var tensorboard, or just directly save the pictures or the output in some files. But maybe there are some potential problems, like you may have some issues like many stacked libraries. Since here we modularize everything into functions, it may not always straightforward for you to add features by yourself. It may take some time to figure out where to modify it and how to make the work more smart when you want to change a little bit thing, and you don't need to modify whole the code by yourself, right? Okay, again, this is an optional submission. It's Cyberton again. The task is do Cyberton classification, but the difference is before the previous exercise is in this exercise we are now doing in Pytorch. What's new is actually you have get more knowledge from lecture 7 of how to train a neural network, and you can use everything from the previous lecture, except convolutional layers, the transformers. It's recently popular network structure, and also the pre-trained weights or the pre-trained networks. Yeah, you can use everything from the previous lecture, except those more useful tools or weapons to make it performance better. Yeah, you can also you should also be aware of the file size and the parameter limited. So for this exercise, what you need to do is to get yourself into Pytorch. You can read some documents and also even the recommended examples from the source code or the other code implemented by Pytorch. And then you need to improve your previous submissions by Pytorch. And here you can still have some time to continue exploring how to select the parameters, the hyperparameters, by tuning it again to make it better and to make the training and evaluation works for better results. And you can also discuss with other students. Yeah, since this exercise is optional submit, so you can just directly share your code on campus-wide, and to make sure you get better performance on the leaderboard. Yeah, that's it. So there are a few questions about the organization. So first of all, we have the post-deadline submission. That means after the deadline, you can still submit to our system to improve your exercise, but it's not counted for the bonus. Means even if you have missed the deadline, you can not upload to post-deadline submissions to get a pass for the bonus. but you're welcome to use it to improve your model. And another thing is solutions on GitHub. First of all, we are not allowed you to directly upload the solutions on GitHub. Yeah, maybe someone would like to show off his roadmap of the solutions of this course, but I think by doing so, you upload the solutions only hurt the future students' progress. They may just directly use your solutions to get a bonus without exploring everything by themselves. It's not good for their progress, right? And then when we find some solutions on GitHub uploaded by you guys, then we will issue it takedowns. And maybe some of you do so motivated by you may think some future employer may care about your GitHub page, but I would say actually a solution for a course is really nothing, since it's not involve any real deep learning project, right? It's very common. You can see many similar solutions. I mean, the question is quite basic. So solutions of our course exercise is not helpful for your future employer. Yeah, that's it. But what you can do else is to actually choose the exercise of later, like 7, 9, or 10, or any other task or paper. You can re-implement it or implement based on the current exercise, and then you can document your whole journal. Like how do you tune in the hyperparameters? How do you define the functions smartly? And also you can create some visualization or oblations with the tables of the results with the results of your change, how to get a better performance. You can create such things, right? And then you can outline your key changes, and also maybe you can make it other story, how to make the deep learning project works better by tuning, or yeah, and you can share your documents with students, with others. Then yeah, you can learn from each other's project to get a better idea of how to train a deep learning network, right? Okay, that's all for this exercise. See you next week.